All right. You can see me, hear me all right? All right, and I can see this, so, okay. Oh, I'm only like, I'm 20 minutes.
So you're one of the presenters?
Yeah, right.
And is the next presenter's slide deck right after yours, or is it all prepared just in case?
Is this off again? Okay. Yeah, I came. All right, let's see. Everybody can hear me? All right, and I'm glad everybody made it up here. I know this was not an easy task to find it, so I gave it a few extra minutes to make sure people could get up here. I've only got 20 minutes, so I'm going to hop into it. I'll be happy if people have questions. I'll be hanging out at least through early afternoon. You're welcome to grab me on a one-on-one afterwards. So let's start with why is generative AI blowing up so much? And I think there's an important thing that's going on here, which is if you go back 10 years, 12 years ago when big data hit, and it feels like it was a lot further than that, it's 10 to 12 years, I always said that big data was a bad label for that trend because what made big data so big wasn't that there was more data, wasn't that it was bigger data, it was that it was different data. So we didn't just have a bunch more transactions or inventory data, we had things for the first time like text and images and web browsing history and so forth. And that opened up entirely new use cases, which is why big data went big. Now, AI's been trending for years, but why did it blow up so much in the past year? And it's because historically, every type of machine learning or analytical model would take a given row or a given example of data and append something to it, typically a prediction, a forecast, a classification. And the early AI, even though it was going hot and heavy for a couple years, was effectively doing the same. Is this image a cat or is it not a cat? Is the sentiment of this specific piece of text good or is it bad? And so while there were definitely new problems you could solve with that, it was the same type of problems with different data. Whereas generative AI, on the other hand, now is something totally different where it uses all of the historical data we have, but then generates a new example of that data in totality. So a whole new image, not classifying an image, a whole new string of text, not classifying a text. And just like with big data then, there's all kinds of new problems we can solve with that weren't previously possible. And so I think that's a big reason why it's gone so big. And there's stuff happening very fast. This is a shot of one of my favorite articles I've read in recent months. This is Decorify from Wayfair. You know, back to company's Morphine, a classic cataloger from the day that's gone online. And what they have, if you look at the top right corner, there's an image that's kind of cut down the middle and there's little arrows. You upload the image of your space, you enter in a prompt, what you're looking for, what color scheme and such. It'll generate an image with products in it so you can see what your room would look like. And if you move that little arrow back and forth, it'll just give you more or less of your room versus the new room. And so if you think about it, historically, if you wanted to decorate a room, you'd have to go to a store, or even if you're on an online site, maybe get a designer to actually mock something like this up, which would take time. You can only get one or two examples. And it was costly for the seller. Now you can go out and with just a few prompts, I could say, you know, I don't want white, I want blue. And it'll instantly update. And what's even cooler is that all of those products are actual products that are purchasable. So it's not just a hypothetical, here's what your room might look like. It is literally, this is your room if you want it. You know, you could either buy the whole set or you could click on certain items and buy the set. And so this is an example of so many different types of analytics coming together, including some traditional AI work, some generative AI, some traditional propensity modeling and such. But when you think about it from a customer perspective, I can now go out and in a matter of minutes have multiple options for both style and product that I might put in my room and buy it and be done. And the retailer, of course, they're getting business much faster. I still think, though, the designer, if you're a designer, what you really want to do, probably much like data scientists, you want to work on the cool stuff. Those designers don't get excited about having to do 10 different quick room mock-ups for 10 customers today, 9 of which won't buy anything anyway. They'd rather be working with those customers that are going to hire them to really do a full classic design, and I think that'll free this up. So I also don't know that it threatens the jobs of designers so much as it lets them focus on the cool stuff. And one of the things that's happening, and this isn't just with generative AI, but it's definitely going up a notch, is this idea of seamlessly embedding analytics and AI functionality so that the users aren't even aware explicitly that they're using it. So if you think back, even 5, 10 years ago, everyone knew analytics was in use, right? You go to a website, you know those offers are building off of whatever history you had and such, but you would just see what they offered you. You wouldn't really interact with the analytics per se. And even with traditional analytics, this is changing. When you go to your credit card or bank account and they say check your credit score, when you go to look at the credit score, and they'll now all have little simulators. Well, you can simulate what would happen if I increased the balance on a card or opened a new account, and they'll simulate what your score would be. So you're actively interacting with a model. This is from Adobe's Firefly product, and much like PowerPoint and Adobe for years have had, type in a keyword, it'll give you real pictures. They've just embedded generative AI now. Type in your prompt, it'll generate images, you can insert them. So you have creative types now who don't know anything about AI or modeling, probably don't care about how it works, but seamlessly in the same interface and with the same style of interaction they've always used are able to take full advantage of the AI capabilities, generative AI. So I want to give you a bit of a contrarian view, this whole battle over fair use, and there's lawsuits all over about training data and such. And so my contrarian view is that if I were to go and study art or music as an example, what's a huge part of what you learn? They make you go out and study past artists, past musicians, learn about their style and why they did what they did and how they did it. And then over time, you're supposed to synthesize what you learn about that art or that music, and then you create your own style, which is by necessity based off of everything that you've ever seen of those artists and musicians. Now, we can't go too far. There's cases, you know, the early days of sampling, I remember it was Vanilla Ice was one of the first people got sued because he sampled too much of a David Bowie song as is and didn't credit him, and he lost a big lawsuit and had to pay royalties and such and such. So the point is, there's already copyright law. And I don't think that AI should be held to a higher standard, though, than we are held to. So if I'm an art student, I could learn, let's say, tens of thousands of pieces of art, maybe. If I'm a musician, tens of thousands of songs, maybe, on the outer edge, of which I would then generate my output. These generative AI algorithms have looked at millions of photos, tens of millions, hundreds of millions, every song ever created. So I would argue that in a way, a generative AI song or piece of art steals a little less, quote unquote, from all of its training data than you or I would steal from all of our training data, because they have a whole lot more training data. So I think there's a lot to figure out here, but I do think that this idea that just because AI looked at an image or ingested a song and then generated something, that inherently that's you know, a big problem. But again, this will be in the courts for years. So the biggest misnomer I think that happens around generative AI is this idea of hallucination. I'm sure everybody here has heard of hallucinations. Show of hands, everybody? Everybody's heard of it. So here's the key to understand, and this is where you folks in the room, I'll bet a higher percentage of you know this by far than the general population. But when you go to Google, you type in keywords, and what Google's going to attempt to do is to match your keywords to real websites, real documents, real tags on real images, whatever the case is. But the idea is matching what you've asked for to real specific items that exist. Now, it might do a better or worse job of that. Sometimes the links won't be as relevant, but it'll always be a real document, a real link, etc. The thing with generative AI, it's in the name, generative. Generative AI is not attempting to match anything to your prompt. What it's doing is reducing your prompt to a mathematical representation, passing it through an algorithm to then spit out a mathematically probable answer. It's effectively making up every single answer that it gives. And so rather than being concerned about the hallucinations, you should actually be amazed that while generative AI is literally making it up word by word every time you ask it a question, it gets a lot of things right, because well-documented things, probabilistically speaking, is the right answer is what the facts are. But there's some nuances here. I went in and asked the same question, tell me the history of the world in 50 words. As soon as the first answer came back, I resubmitted the exact same question. If you read that, neither one of them, I would argue, is wrong, although there could be some actually wrong facts in those if you really look carefully, but they're also not the same. And the interesting thing, after I posted about this on LinkedIn, a friend of mine then went and did the same experiment, and within, say, ChatGPT and similar tools, within the context of a single session, it retains some memory of it, and that's why those two answers are very similar. This other gentleman submitted the same question, and what he got, two similar but different answers, but in my case, it's really a humanity-centric history of the world, about civilization. Both of his answers started about, 13 billion years ago, the earth formed, and then there were dinosaurs, and then, at the end it says there's people. And so between he and I, we got 4 answers, none of which were wrong per se, all of which were different, and his versus mine would have given a completely different impression of the history of the world. So you just have to be aware and be cautious when you use the generative AI that not only could it give you wrong information, but it might not even give you the same information a minute from now, let alone if one of your colleagues goes to replicate it a week from now. So what will it get right and wrong? This is actually discernible. First thing, any recency is important because the current models that are public, I think it was the end of 2021, they were cut off. So you ask something before that, it might do a pretty good job, but you ask, say, about the Ukraine war, there's 2 problems with that. One, it didn't exist in 2021, and 2, there's a lot of conflicting documentation of the war in Ukraine, and so probabilistically, who knows what you're going to get. But equally important is obscurity. So if I ask about World War II, and I ask about Pearl Harbor or Winston Churchill, the most probable answer is probably pretty much the right answer because Pearl Harbor is highly documented and very consistently documented, Winston Churchill. But if I go and ask about an obscure colonel and an obscure battle in the middle of Germany, I mean, who knows what you're going to get? It's probably half made up. It might be all bogus. So I've gone and asked it questions about myself, and it came back. I remember this one really threw me. It said that my first book was nominated for an award by Informs. And I was like, I don't remember this. And I said, well, maybe because I got nominated and didn't win and no one ever told me. I just didn't know. I went and poked around. I could find no record of it. And so even with myself, and I know my history, it made up a very believable award by a very real organization that would have had exactly that award, but then, my book never had it. So anyway, I didn't update my bio with that award nomination. So the point is, if it can fool me about myself, you got to remember that it can fool you very easily on other things. If you want facts or subjectivity, people have, I think, wrongly said that this is, general intelligence, sentient, because it can pass an SAT or GRE and so forth with a high level. But think about those exams. They ask a very specific question with a factual answer, and then there's 4 options that you choose from. And so back to probabilistically speaking, if I say, who won the case of Brown versus Board of Education in 1970, whatever it was, or 1960, whatever, the point is that ChatGPT should do a good job of something like that because it's a well-documented case, the outcome is known, and probabilistically it'll probably get the right answer. And so a lot of those standardized tests are testing your ability to recall some general facts more than it is that you're really having to think through complicated topics. And then last, you don't want it to do math or any kind of computation because remember, it's not a calculator. If you say, what is 1 plus 1, and it says 2, it has not gone and calculated that 1 plus 1 equals 2. It is probabilistically saying, if I see the string 1 plus 1, what is the most likely next answer? And there's enough 1 plus 1 equals 2 out there, it's probably going to get 2 almost every time. But you can go out and find examples of even late elementary school math. It'll mess it up left and right. It'll do the wrong order of operation in a complicated math problem. It'll put an extra parentheses. And it might even get 80, 90% of it right, but then that one thing it gets wrong makes the entire answer wrong. But this isn't to say it's not at all useful. So here's a prototype I saw that Amazon's about to roll out. When I go to a product and I'm looking at reviews, I get stressed because I feel obligated to look at a bunch of reviews, the positive ones, the negative ones, and I try and figure out what's the general pattern here, and it's the things I care about going to be affected. What they're doing here is they're taking those thousands of reviews, passing it through and saying, give us a paragraph summary, and then see if you can tag any of a number of important things like performance, ease of use, that this appears to be positive or negative on that. And so the beauty of this is we don't care. It doesn't have to be the exact same answer like those examples I gave you earlier. As long as it's generally the right direction, that's what we need. And in this case, they probably freeze this and it'll show it to everybody who asks for the summary reviews up until at some point they'll refresh it and give it to everyone. So it's not like I'll get a different answer the next minute, the next person gets a different answer. And so these are these nuances where this would be an incredibly powerful approach that will leverage all the strengths of these models without actually the negatives. Whoops. This thing just did a double click. So one of the big risks we have is this idea of model collapse. And so any kind of model, as you know, it kind of regresses to the mean. You tend to trim off more and more outliers each pass. So on the top is a real distribution, and as you move to the right, that's what happened over many iterations. First, the distribution changed, then it converged on a point. Down on the bottom, the classic handwritten numbers. As you take a bunch of the original human-generated data and pollute it with more and more algorithm-generated data and retrain it, it eventually converges to a bunch of like blurry zeros and ones. And so the power of the current models is that it's almost all human-generated content, training them to predict human-generated output. We're soon going to have more images and more text than was human-generated. It might almost be true today, but we're talking very short time, and if we don't filter it properly, we'll basically have generative AI become completely useless because we won't be able to have a good model anymore because we polluted so much generated stuff that comes down to the mean. So we have to figure this one out pretty quickly. And then this gets back to just don't force generative AI where it doesn't belong. You gotta be thinking about what's the task you've asked for. If you want to know how much inventory is left, you don't want it to generate a probabilistic answer. You want it to actually go look up that answer. If I call to know, is there a seat available on that flight and how much does it cost? I don't want a probabilistic guess. I want an actual answer. If, on the other hand, I want to know, are these reviews generally good or bad? Can you give me the main themes that someone's talked about? Or here's a draft I just wrote. Can you double check this for some grammar and such? It makes a lot of sense. And so what we're going to start to see, and it's already happening, is this idea of ensemble approaches using multiple types of models, multiple types of things. And you have to think about ChatGPT, everyone talks about. That's the app on top of the underlying model GPT-4. These underlying models are already commoditized, right? You can use Microsoft, OpenAI, all of these. You don't need to build your own. But you want to build layers on top. And so back to the math problem. Instead of asking, do math, have the prompt parsed and realize here's a math question and pass it to a math engine. That's what Wolfram has now. It'll extract the parts that are asking a math question, do a computation with a computation engine, and spit it back. And so what I see over time will be, first of all, you'll submit your prompt to multiple large language models and then reconcile, say, 3 or 4 answers together in an ensemble approach, and this engine over here might have made something up, and this engine over here might have made something up, but hopefully that'll be the parts that aren't consistent, and the consistent parts across the 4 will be mostly the accurate pieces. So I think we'll have plugins for physics, for chemistry, for certain types of physics, chemistry, math. And then last, I'll leave you with, this is where I think the real value of this, if you want to differentiate as a company, is build these application layers that are going to parse out the prompt, identify what part of this prompt needs what type of information, computation, input, and maybe part of it goes to a traditional Google search to actually look up some documents, while another part goes and does some math, another part looks up something about the chemistry, and the last part crafts some kind of paragraph summary of the information that was found. But I think this is where this value of all of this is going to play out. Those underlying models will be a commodity. There will be companies generating, let's say, generic add-ons, and then as an organization, what you all are going to need to do is generate your own little add-ons and plugins that you can put on top, and you'll get your most value. So with that, I think I'm right at about 20, and I'll say thank you for coming. I'll be around for an hour or two.
Hey, hey, hey. Hey, 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 1 2 1 1 2 2. Check. Hey, 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 hey. Hey, 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 1 2. Hey, 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 1 2. Check. Hey, 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 1 2. Check.
Yo, buddy. Appreciate that.
Hello, hello, hello.
Kind of muted right now just because, like, we're right here in the house, you know? But if hey, the double doors right there. You just walk through the steps right there.
Hello, 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 hello. Oh, nice. It's working. Okay, nice. All right. I guess we can get started. I don't really know if I'm like expected to wait for people to sit down, but thank you guys all for coming. I'm here to talk to you about vector databases in AI. These are going to be a core part of the large language model stack. So, pay attention. I'll start off with a little bit about me because I'm not that important. While people are still talking, it's fine. So my name is Yujin. I have a AI ML background. I've been working in this field for maybe like 10 years. I started at IBM as a software engineering intern when I was 16. I did some research on machine learning and published some papers, and then I went to Amazon where I worked on AutoML. And then I went into natural language processing, and here we are at Zillis working on the cutting edge of what's going on with large language models. Then let's cover who Zillis is. You may have heard of Milvus or GPT Cache. These are both very popular projects of ours. Zillis is the company that maintains these projects. We were founded in 2017. We're based in Redwood Shores, California. So we're out on the West Coast. If you are ever out there, come say hi. I flew in last night at 1 a.m. So now let's get into the actual meat of the talk. It seems like most people have kind of settled down, so I can start actually talking. So why do you need a vector database? How do vector databases help? How do you evaluate a vector solution? And then some tips for getting started. This is what we're going to cover today. So I'm going to start with, why do you need a vector database? Okay, so vector databases are the solution for handling unstructured data. And unstructured data is everywhere. Okay, here we go. This is working again. So unstructured data is all around us, and a lot of numbers float out there around how much it really is. And there's this trope of 80% of data is unstructured data, and 90% of that data is not analyzed. So it's not used right now. So how do you use that data? Use it in vectors. And you can really use this with any kind of data, text, audio, images, videos, whatever you want. Okay, some common AI use cases for vector databases. Hello, hello? So use this one? Is this thing on? Okay. All right, now I have a working mic again. I'm gonna sit down. All right, guys, so we're gonna talk about some common AI use cases. These are some use cases you can see up on the screen, but the main idea I want you to get from this slide is vector databases are critical to similarity search and pretty much the only existing solution. And then I'm gonna go to the next slide where I'm gonna highlight the one thing that you guys probably wanna hear about the most: large language model, augmented retrieval, retrieval augmented generation. This is also the most popular case for vector databases. Okay. So the reason why large language models need vector databases is because they hallucinate. You guys have probably seen this in the news by now. There's a lot of news around ChatGPT and what's been going on with it. And recently we've seen some pretty crazy things, like a lawyer using ChatGPT and getting in a lot of trouble. And you don't want to be that guy. And you also don't want to be the guy who says that, like, France gifted Lithuania the Vilnius Tower in 1980, because that's not true. So the reason why large language models have these issues is because they're neural networks. And this right here, this example, is an image of what GPT's architecture looks like. GPT is a decoder-only architecture. And what that means is that it takes a set of state encodings, and it transforms that and predicts the next token or word out of these encodings. So for example, the image shows that the chicken walked across is the input, and then the output is the prediction from ChatGPT or GPT, whatever, and it says across the road. So this is essentially how GPT works. And so an example use case in real life of using this with large language models is you essentially have some documents. If you are working at a corporation, if you're working at enterprise scale, you probably have hundreds of thousands, millions of documents, and you want to be able to query these documents, right? I mean, I don't know if you guys saw the research back in the 2000s that showed the average knowledge worker takes almost 2 hours a day to query these documents. And so it's much, much more efficient to use something like a large language model. And in this case, we have actually built an example of this called OSS Chat. And you can check it out at osschat.io, and it allows you to chat with open source open source software. And if you have an open source project that you want to submit, you can go to our site and submit it. Okay, so the way that this LLM hallucination is prevented is basically by inserting your data on top of the large language model, right? So you have your large language model as your underlying compute, and then for you to be able to access